In our last lecture, we have discussed the pseudocode of GCD of two non-negative integers. Now in this session, we will write the actual Python program for the same. So here you see that I have already opened up my Jupyter Lab window, and within this Jupyter Lab, I have written out the pseudocode. So if you remember, we have used two pseudocodes. First pseudocode was with this if-else block, and the second one is with this while block. These are of course not code, because you see that these are raw window, which means that these are just plain text. These are not code. If I want to have code, I have to go here and I have to select code, but these are not code. So now I want to convert this to a code. My top one is this if-else block type pseudocode, and the bottom one is this while loop type pseudocode. Now let us see how we can convert this pseudocode to actual code. And this is where the utility of pseudocode will be very clear. So let us start working with this bottom one, that is this while loop. So here once again our input is two non-negative and at least one non-zero integer mn. Output will be GCD of mn. So here the idea is that while m not equal to n, I have written not equal to like this because this is simply plain text. If m is less than n, we want to swap m and n such that m is always greater than n. And then I take a new m, which will be m minus n. This is where the while loop ends. And at the end, the m what we have, that would be equal to n, and then either this m or this n, whatever you wish, that would be our GCD. So let us see that how we can take this algorithm, this pseudocode, and make it a program. So first we create a window just like this below. So from here we can insert a cell below. So we inserted a cell below, and this is my code cell. Within this code cell, let us first copy this part. So I have copied this part. It is showing color because it assumes that these are Python. So whatever the Python keywords here, it is coloring it, but it doesn't necessarily mean that it's a right code. Of course, to make it a code, I have to give some value of m and n. So if I do give some value of m and n, let us say we were discussing other day that this 45 and 18. So 45, m equals 45, n equals 18. And this is not a Python code yet, so we cannot run it. One way to learn coding is that you try to run it and then you take out one after another error that the program will give it to you. So for instance, if I press shift enter here, shift enter, then it says that immediately it gives that this is a syntax error, invalid syntax, that m not equal to n, because Python does not have a sign like this. So we know that what is this non-equal to comparison operator, that would be in Python is an exclamation type mark equal to. So that would be the sign of not equal to comparison. So I have changed this, so this error will be gone. So let us say I try it once again. Now you see that it's saying that while m not equal to n, this is expected a colon here. Okay, so let us put a colon here, because we know that we need a colon. So I put a colon here after this m not equal to n. In fact, these gaps, it doesn't matter, so we can take out the gaps here. So m not equal to n colon. Okay, we try to run it once again. Then it said that this show up, there is no such thing as show up in Python. So we have to, now the way is that how do you show up then two variables in Python? We don't know that. So what you do now, if you are a beginner in Python, you go online and search how to show up two variables. So for instance, so you can go here and you can give a search that how to show up two variables in Python. So how do you show up? So you see that certain search items are coming. So take a look that how do you show up two variables. So this is of course how do you show up two variables in any standard programming language, that you take one variable, you put it in some container temp, then in X you put the value of Y, then in Y you put temp. So this is a standard technique in any computing language for swapping two value. Now Python of course has something much more elegant. So for example, this x comma y equals y comma x. This is the way we can show up two variables in Python. So then we take that and we put in here. So swapping in Python basically means that f comma n equals n comma m. So now we have swapped it, but then we cannot write it this way. So can we? So let us say that we write it this way, and we now you see that it is giving, we try to run it, but it is giving invalid syntax. Why it is invalid? Okay, because we need here a colon, and the usual practice is that after if the next statement comes here like this. So here once again I try to run it. You see that this is giving end while, it is telling us that it is invalid syntax. We don't need end while. We don't have to explicitly close a loop in Python. This is just it. We remove it and Python should work. So indentation gives the indication to Python that where the loop is being closed. So let's try it once again. So it says that GCD mn, because we have not actually defined this GCD mn, so Python doesn't understand what it is. We do understand what it is, but Python doesn't. So what do you do then? So let us say that I simply write that print GCD, and my GCD is going to be simply a string. So print GCD equals m. That looks all right, it seems. So let us run it once again. You can see that the program ran. So it gives GCD equals 9. So essentially, without knowing much about Python, we have completed the program. So this is the beauty of writing pseudocode. Now the point is that how can you make it better? Well, there are various ways this code can be made much more elegant. First of all, you can make it slightly smaller. So this after if we always indent, and if you make a mistake in indentation, it will give you some wrong results or it will throw you some error. So you can also write in this way, in one line if. So let's see if it works. It does work, that you can see. So it makes code much more elegant. M and n are two variables that we have defined. You can define them in one line as well with a semicolon. Let's see if it works. It does work. So it makes your code much sleeker. Okay. So now you know that this is something, this code is something that we can use it as a function so that we can give this m and n as input, and then it will bring the value of GCD from that function. So how do we write it? To write it, what we have to do is that we have to make this a function. So let us just copy this and put it up here. M45N18 is something that will go into the function. So we take it out and we put in here. So whatever there in the while loop, that is our function. So we define the function GCD, which will take these two values m and n, and we need a colon here. So this is something, once again, you can go online and check that how to define a function in Python. In 1 minute you will get the answer, but I am directly giving you here. So you start with this, then you need an indentation. So m and n are coming from somewhere, then you need an indentation. Then here you have this indentation. Here you have this indentation. It completes the program. And then here you have to write return m. Here what we'll do, we are sending, here my function ends. I am sending this m and n values to the function, and function will give me back GCD m and n. So here what we will be writing is GCD m n. So this is a much better way of writing the program. My GCD has now gone into a function, and this is an user defined function. This function is not inbuilt in Python. So if I now run this, what happens? Well, it happens the same thing. GCD equals 9, it is giving us. So the program starts operating from m equals 45 here, and then it hits this GCD, and it looks at the GCD is something that we have already defined. It goes there, it follows whatever it has to do here, and then at the end it returns this particular variable m. You can also, what you do is that this second part of the program, which is dangling outside, you can put that also in a function. That is a much more modular way to write a program. So for instance, the second function, we write most of the time that as main function. So main function doesn't take any input because inputs are given within the main function. So this is the main function. Okay. So now both are function. Main function doesn't take any input. It doesn't give back any output because whatever is happening within the main function. Now if we run the program, now program is in a problem that where it will start because it only see two functions. So we can instruct specifically that you start from main, and we write that just like this. So then the program will start from main, and if I now run it, it will run and it will give me GCD equals 9. So this is something that we are now very happy about. This is a very modular type program, very good program. If you want to check the program with several different values, you can do so. You are free to do so. Change this m and n and play around with it. We might have made a mistake that we don't know. So you play around with it, see that how it is. And we have to be very sure for a program about its accuracy. That is why we test it all the time and try to stretch its limit for whatever the inputs it can work. We try to work it for other kinds of input. So for instance, you can check it with, let us say, 45 and 75, and let us see that if it is doing the right thing. So it is giving 15. Yeah, so 45 and 75, 15 is the GCD. So we are doing all right. when m is less than n or when m is greater than n, both way we see that we are getting a correct result. So we are good to go with this. Now let us look at the other type of, this is the second type, while loop type algorithm, and from that while loop we have created a while loop program. This is good, but how we do with this if block? So from if block, this is my pseudocode or algorithm with this if block. So let us see that how we do it. So we follow the similar procedure of modularizing my program, and to modularize I have simply copied that our last program here and I have pasted it here. But now you see that we want to use this kind of an algorithm. So how we can use it? Well, the main program will not change, but we wish to change my function here. My function will now have this if block. So if I write it in if block, the first thing I will write that if m equals n, and here this equals n is a comparison operator, so we need this double equal to sign. If m equals n, it will return m or n. So if I send this m and n equal here, the function will simply terminate here. It will check if m equals n, it will simply return m and it will not do anything else. Then if m is not equal to n, so what happens? If m, so we write it differently. We write it, let us say that I give a structure here, okay, and we put an else block here. Within this else block, if m is less than n, I'll show up it and I'll put this m equals m minus n. But now what I will return, because this is not a loop, this will not keep on doing it. Although I have written here continue, this will not, if block will not continue. It will terminate here. So what I'll do, I can write that call gcd mn. So this will return gcd mn. So this is a very interesting feature, and this feature is something that we call recursion. Okay, so here in continue, what we want to do is that we want to use recursion. So recursion is the feature when a function invokes itself from within the function. So what will happen here is that if m equals n, then of course it returns m and nothing further happens. If m is less than m, it shows up, it changes m equals m minus n, and after doing so, it returns gcd-mn. So gcd-mn, then again the control comes here in gcd-mn, and then again it checks that if m equals n, if m equals n, it will send it back. Otherwise, it will come here and it will keep on doing this, so, which means that eventually it will hit the point where m will be equal to n and it will return m. That is how the program will run. So this is the beauty of recursion. So let us see that if we have written it properly. So let's try to write it. Okay. So here it is saying that no, there is an error. So where is an error? Okay, the error is that it is expecting a colon here. We miss the colon. After else there will be a colon. So let's hit it again. Yes, so it is giving us GCD equals 15. So we are right here with our recursion. So now you see that how you can write a program, how you can modularize a program, how you can test your program with many different values. And these are super easy in Python. You keep on taking online helps where it is necessary. In last session, you went through an exercise where I asked you to write an alternative form of pseudocode for finding GCD of two non-negative integers. So what you can do now, you take that and from the pseudocode, you write a Python program. Just like this. You may not know Python very well. However, taking online helps just like I was taking, you can write Python program efficiently. That's all for this session. Thank you.